Namaste. Welcome to this channel, Chemistry Made Easy by Dr.ARM. Today we will see the topic that is atomic structure, and today's point is the Aufbau principle. In this topic, we are discussing the Aufbau principle, and up to this time, by this time, we have seen some of these rules which are considered under this Aufbau principle. That is, one is Aufbau principle, second is Wood's rule of maximum multiplicity, third is Pauli's exclusion principle. So we were last time discussing this Wood's rule, in which we have also seen what is Coulombic energy and what is exchange energy. So this Coulombic energy is termed as, represented as pi c. So this is arising because of the repulsion between the two electrons which are in opposite spin. So this is arising because of such electron pair, where one electron is with plus 1/2 spin and another is with minus 1/2 spin. Means these electrons, when come closer, because of their negative charges, they show repulsive forces, and because of this, energy of this electron associated is called Coulombic energy. Similarly, there is another term that is exchange energy. So when we have unpaired electrons, two or more unpaired electrons, then the energy required for the exchange of these electrons in order to change their positions is called exchange energy. So this exchange energy is arising because of such unpaired electrons, and this amount of energy, the energy is with positive sign, this is with negative sign, this is constant, this is also constant. Now we will see that the higher the possibility of these exchanges, lower is the value of this exchange energy. So when the electronic structure has such paired electrons, they will contribute this Coulombic energy, because of which the energy will rise, the energy of the system or electronic structure will increase. And when there are unpaired electrons like this, at least two, then it contributes the energy called exchange energy. It is negatively charged, and therefore more exchanges of this type will show more negatively charged contribution of this exchange energy, and because of this, the energy of the system or electronic structure will decrease. So this will help to stabilize the atom, and this will help to destabilize the structure. So Coulombic energy, higher the amount of Coulombic energy, it will destabilize the electronic structure, whereas higher the number of exchanges, it will result in more the exchange energies in more negatively charged exchange energy. Therefore, it will contribute to stabilize the electronic structure. Now we will see the example in which we will find how it is observed. So say this is the energy axis. Now we will see this first, that is, say it is px, py and pz orbitals. And if we are having the electronic structure like this, so if we are having two electrons, it can be distributed like this. Now if we are having another situation like this, the electrons are distributed like this. Here spins are opposite to each other, here spins are opposite, but these are occupying different inner atomic orbitals. Here both electrons are occupying same energy atomic orbital. And again, if we arrange the electrons with same spin in two different atomic orbitals, we find this situation. Now we observe that the repulsive forces between the electrons are producing the Coulombic energy, and this is one Coulombic energy. Now here there is no exchange, because the electrons are of opposite sign or opposite spin. Spin state is opposite. This one is with plus 1 up, another is minus 1 up. Here both electrons are of same spin. So there is exchange possible. So here we will show this exchange, how it is shown. See, this is electron number 1, this is electron number 2. And if we are having the two electrons like this, so first electron will go to this position number 2, second electron will come to the position number 1. So we label these electrons like this, 2 and 1. So here we find that the positions are exchanged. Electron number 1 goes to number 2 position, electron number 2 comes to first position. So we get this type of arrangement. So there is only one exchange possible. Now because of this, the energy of the system is lower. So this is, it has negative value. So this pi e is negative and this is positive. Now we can distinguish between what is pi c. The energy difference between these two structures is called pi c, that is Coulombic energy, and the energy difference between these two is called pi e, exchange energy. So in this way we can observe that the two terms are here distinguished, that is what is Coulombic energy and what is exchange energy. Now when these two terms are added together, that is pi c plus pi e, it gives us the pairing energy, that is pi, pairing energy. So pairing energy is the addition of Coulombic energy and the exchange energy. Now we find that the difference between the energy levels involved, will determine the final structure, that is electronic structure of the atom. Now if we see there are two such sets of atomic orbitals, this is 2s and this is 2p orbitals, then if we are having two electrons here, then energy of these three orbitals, this is one set, this is called one set, this set is different, and this set means having only one atomic orbital, so this is another set. So these two sets of atomic orbitals are different, so their energies are also different. So these electrons cannot go here, or the electrons of this cannot come here. So the electronic structure is dependent upon the energy difference between these two sets. So if the energy difference of the two sets are larger, then electronic structure shows that the electrons which are present in the one set cannot move into the another set. So in case of another, maybe this is the general, but when there is some exception, like if we consider say 4s orbital and 3d orbitals like this, 3d orbitals like this, then we find that when we are having these 2 electrons in 4s. So this 4s is filled first, then remaining electrons can go, means if we are having any more extra electron, then it can enter into this 3D. So unless this is filled completely, the electron cannot enter into this 3D. Means we have to complete the set of first electron, first atomic orbital with its capacity. So this can occupy maximum of 2 electrons. So we should distribute 2 electrons first here, and if we are having third more electron, then we can place here. Again, if we are having, say, the electrons like this. So if there are 4 electrons in the unpaired state, and if we are having the paired electron like this. So in the case, here we find that energy of the 2 sets is nearly same energy. Means there is slight difference in their energy. So electron can exchange between the 2 sets. So here the electron is moving from this state to this state. Here, so we can distribute the electron like this. Now this situation gives us that the number of unpaired electrons becomes 5 here and 1 here. So 4s as well as 3d becomes half filled. So this is half filled structure, and it has greater possibility of exchange energy, or electronic exchanges are more possible. So this is more stable because the pi's are more, means exchange possibility, possible exchanges of electrons are more. Now we will see one example of this type. So if we take the example of oxygen, so if we take the example of oxygen atom, we have 2 situations. The situation number 1 shows that in case of we are having electrons like these 4 electrons, and there are these p orbitals, and these 4 electrons are distributed like this. 2 electrons goes in with pairing, and 2 electrons are going with unpaired state. So this is situation number 1. Then we are having situation number 2, where the distribution is also different. Now we will see in this case, all the 4 electrons are in the paired state. So we have to show that we have to find which is more stable. And what are their pi c and pi e values. Now if we take this situation number 1, we find that the electrons are like this. There is one pair of electron. So here this pair shows that there is 1 pi c, means repulsive forces between these 2 electrons are producing the Coulombic energy. So there is 1 electron pair, so it is 1 pi c. and in this case the we obtain that. Now again another term, that is so in this case has one electron. There is one electron with downward spin, means opposite spin, and other 3 electrons with same spin. That is, say if these 3 electrons are having -1/2 spin and this has +1/2 spin, and because of this the exchange is not possible, means every electron cannot undergo exchange. So here no exchange, here no exchange is possible. So we say here no exchange, and therefore pi e is not available. Now if we are having the third situation, like the 3 electrons, if we are having 3 electrons as shown here, the total number of exchanges possible are 4 exchanges possible, means this one arrangement plus 3 more arrangements. So totally there are 4 exchanges possible. So overall, so here we can show that there is the energy associated with this is called 3 pi e, and here in this arrangement we have no exchange value. So overall there are 3 pi exchanges, means we can show that the Coulombic for all these structures, we show that the pi c, means Coulombic exchange is 1 plus the 3 pi, means this is including this there are 4, but excluding this there are 3 pi e structures. So because of this the arrangement is like this. So the electronic structure will result with the help of this situation, and because of higher value of exchanges, higher number of exchanges, this gives more stable structure because the energy of this electronic structure will be less. Again, if we are having the structure number 2, that is situation number 2, the situation is like this. So in this situation we find that there are 2 electrons, means 2 pairs of electrons, in which 2 electrons are with +1/2 spin and 2 electrons with -1/2 spin, and because of this they show the 2 Coulombic pairs. So this shows 2 pi c values plus these 2 electrons, means the electron with +1/2 spin or -1, means these electrons can also undergo the exchanges. So there are 2 exchanges possible. So we have 2 pi e. So this exchange means this electron can come here, this electron can come here, or this electron can come here, and this electron can come. Means the total we have 2 exchanges. So the overall energy of this arrangement is 2 pi c plus 2 pi e. Means if we compare these values, with these values, so you will find that this is relatively low energy value, because Coulombic energy here it is less, here it is more. Here the exchange energy is more, means actually the magnitude is less, means negative value, it is negative value, and this is positive value. So we are adding the terms, but it has negative value, this has positive value. So this will give us the net energy higher value. It is higher value of energy, and this is lower energy value of the system. So this is more stable, this is less stable. So in this way we can discuss this first example. Now we will discuss another example. So if we take nitrogen atom, we have the three different atomic orbitals of px, and it has 3 electrons distributed in this way. So this is one situation. In second situation, you will find that the arrangement is like this. Out of 3, 2 will go for pairing and 1 will remain unpaired. Now here we observe that there are 3 unpaired electrons. So there are 3 exchanges possible. Means the electron number 1 can go here, 2 can come here, again this 1 electron can go here, 3rd can come here, again this 2nd electron can come here, and 3rd electron can come here. So there are 3 such exchanges possible, means 3 pi E value is possible. But here we have only this 2. There are 2 electrons with same spin. So we have here 1 exchange possible. 1 exchange possible. And because of this, pi E is 1. And plus there is 1 unpaired electron. Pi E plus 1 unpaired electron means 1 pi C. So 1 pair of electron gives pi C, and 1 exchange gives 1 C. Now this is positive and this is negative. So total amount of energy is resulting in higher value, and this has negative value. This 3 pi E are more negative. So this is much lower energy state, lower energy, and therefore it is stable. So this is more stable and this is less stable. So we have to prefer this type of electron distribution. So with this we will stop here and we will continue the discussion remaining in the next lecture. So see you next time. Please subscribe to this channel. Please place bell icon and like button. So thank you very much for watching this video.